Hello. Okay, let's continue what we were doing. Let's just this. And okay, what we were doing. Okay, let's go to the project first. And we had this project on GitHub. And it is a rule engine where you can define rules in a format of source of events, a condition, and an action to do based on that event, and the destination to the output of the action. So you say when X happens, if it's like valid, then you can do condition, like you can do action Y and do this action in this place. So you can say when the user press the K key or the K key. I couldn't really pick another character. The A key or the space bar. So when the user press the space bar, or when the user press any key on the keyboard, if it's the space bar, then you can like move the or like jump. And this jump is an action that happens on the canvas or on the screen. Or in business, something like when a message is sent to Kafka, or when you receive a message from Kafka, you can filter, like you can say, okay, like if it's valid, then like minify it, or convert it to another type or another structure, and the output would be to write it to a database. So you are defining your system in terms of source of event and destination to events. So source and destination, and the event is moving from the source to the destination, and it can be transformed and it can be filtered. Something like sometimes the ETLs pipelines do the same. So you're getting the data from one source or more, you're joining, filtering, and transforming stuff, and then storing them somewhere else. So this is what we're trying to, and we have a challenge here because it seems like it's too easy to do that. The challenge is that we don't want to have any escapes to the heap. We are doing that here. We're doing that as a like a we're doing it as just a second here. We're doing it as a Go project, and we are trying as much as we can that the core of the project doesn't allocate memory, or to be more accurate, when the compiler compiles the code, it wouldn't say anything about escaping to the heap. The problem is that you can't really know or define exactly what the compiler or where the compiler will allocate memory, but our goal is you try to check your package and it says, okay, there is no escapes to the heap. That's the main thing that I'm trying to avoid. I can add more restrictions in the future, but let's start with this one. And these are our to-dos. So forcing immutability, source destination, adding tests, and we also made sure that there is no dead code. Yeah, so if we came here and we say make lint, there you go. There's no escapes. There's just this unreachable function because we didn't use them yet. We defined them yesterday and we didn't use them yet. That is okay. That's all right. Okay. So now what we were trying to do yesterday and we ran out of time is this. We need to have for like 100 rule that all of them are listening to the same source, like a keyboard or mouse. We shouldn't be initializing the keyboard or the mouse multiple times. We should be initializing that source once, and it emits the event once. it calls one function, and then the system would execute all the rules that are based on this source. So it kind of fans out based on the source. Oh, like, So my dog just sleeps all the time, and sometimes he snores. He sleeps like half eye open. Anyways, I need to keep this on. I need to keep it on. So I left it here, and then did it just turn off? Okay, it's working. Yeah, one of the things is that I wanted to increase the font size so it would be readable on the phone. So if somebody's watching from the phone, it would be still readable for you. I don't know if this is readable or not, but anyway, if you're watching from a phone, please let me know. So I think, can I just open the video like a normal human being? Here we go. I guess it's good enough. Though this is... Maybe I need to increase the font size a little bit. So it's 30 now, right? Let's try 40. Oh, God. Okay, this is readable on the phone, so I guess that would be it. And this... Okay, okay. It's hilariously large, but okay. So, what is that? Like 35 maybe? Okay, I think that this works. And it looks fine on a phone. So, I hope this helps. Now let me open... I need to open the stream manager, that's all. Open. Yep. Here we go. So... Here we go, okay. Today we may be able to stream for longer than yesterday. So make linked, and here we go, reachable function. All right, thank you very much. Now we need to continue having this one source, multiple rules. So what I'm thinking is that when you are here, when you're adding a rule, or come on, when you add a rule, add rule here. When you're adding a rule, we are connecting it to the rest of the rules, right? So what I think should happen also is that we search for the next rule that has the same source as this one, and you also make a kind of a linked list out of them, or double linked list. So you would have a linked list of all the rules and a linked list of the rules that has the same sources. So every source would form a linked list of the rules. Every source will have its own rules as a linked list, and that would prevent any kind of heap allocation, because all we are doing is searching and assigning pointers. So this should be great. Okay, so we need okay. So let's first try to search for, so before we do all of this writing, we are getting the tail and same source head, and we're getting the source registry. What we need to do is we can't initialize it, right? We're not gonna initialize it. What we are going to do is we need to just look for it. So here, okay, so here, so we try to find it and get same source head, yeah, and you're getting the rule dot source, like when, right? It's when. Here you go. And yeah, so you're trying to get it, and if same, because you know, if you try to get it down there, you already modified the linked list. So if you're trying to iterate it after that, you may hit that same element. So you know, you can just avoid all of that by getting all the information you want in the beginning and then do all modifications in the end. Yeah. So rule set next same source to this one. Next same source is this. So we are going to do exactly the same, right? So we are going to get, so this is the head. We need to get also the tail, and we do the kind of thing, you know, do the thing. So same source tail, get previous of the same source head. Oh, this is nice. The AI is helping, I guess. Yeah, so we got the tail, and we need to do something similar to this. But instead of head and tail, it will be same source head, same source head, same source head, same source tail, same source tail, right? And instead of set next, and it will be set. So we're doing exactly the same, but using the other functions that will assign the other pointers. Set, okay. Because we didn't define that, so it really doesn't know the type, but all right. Rule set ref same source detail next same source. All right. We need to review this assignment here because I'm doing it while I'm blind a little bit. Review this for correctness. And here, get same source head. So we need to do an iteration similar to the iterations we did here. We did an iteration that looks like this. I'm not starting. Just, yeah, next. Okay. Yeah, so we are starting from registry, and if it's not nil. Wait, what the current will never be nil. Why am I checking for it? Okay, let's leave it for safety. Remember something. Add nil away, because nil away can really protect you from any like panics where you're trying to dereference a nil pointer. It's a really nice program. That's here. I don't know if it's included in Golang nil away. No, it's not included. So I need to add this. So when you run it, it can check if you have any like rogue code that can just dereference a nil without checking. So it really protected us multiple times from bad code. What's going on? A new follow? New follow. Oh, thank you. I didn't see the name. All right. Nice. Yeah, our goal, I didn't modify the goal, did I? Yeah, manage goals. And we need to start a new goal. And the new goal would be 60. Right? Let's not be greedy. Let's reach 60, celebrate, and then we can... Oh, nice. And then we can get another goal after that. It helps to take it like step by step. Just so I can celebrate a small success. Alrighty. Okay, this is nice. Sense of accomplishment, enjoying coding, working on a nice project. And I also got this, but I'm not sure if I should drink it. I know it's bad for me, but damn. Get some. Okay, so we are getting the registry and the source. No, that's the problem. The source has to be generic, right? The source is generic. So how would you check if the source of the rule equal to... Okay. So let's say is that the reason I had to make sources return an ID because I couldn't compare them to each other? Is that the reason? Could be. It could be. All right. Let's not... And this function is generic. Add rule is generic. Yeah, it is generic. So we can actually have this. So you can say t any. Let's do it that way, and then we can try to improve it. So you are getting a source, and then you are going over every one of these registry, and now you need to compare, right? You need to compare. But the problem is that this source is a type, and the registry you are going over doesn't have a function, because it's an interface, right? So it doesn't have a function that tells you okay, so it's hard to explain. Okay, let's look at it this way. Let's look at this. So you have source, you have registry. Yeah, so you see, you have get next, set previous, get previous. Okay, get the context, start, and get source registry. Get source registry, return this. All right. So what we are trying to do is to iterate over this interface, the registry, and then we need to compare the current registry source to this one. How do I compare it? Do I just wrap them? Can I do this? Can I do it? So can I just say wait, so if I have a structure and I make a unique out of it, is it going to always generate the same ID, the same unique ID? You know, the new package in Go, unique. So, you know, let's do it the dumb way first. So get context, get source, and it's going to return any, right? Any. And here, so the current source is get source. Yeah, this is the thing. I don't think I need the type. Right, let's not look for the type now. And it doesn't, even if it's nil, that's all right. So if current source, I can do that, right? Equal source. I can do that. I can compare both of these any, right? I feel I'm hesitant to do that. I feel I'm doing something wrong. Is it wrong? Okay. Anyway, so we have the get source, current source, blah blah blah. Otherwise, we're going to return nil. Yeah. So now when you do this, it will get you the head. And yeah, we need to implement, of course, the new function, which is get source. Well, yeah, it's kind of removing the genericity. How do you say it? Like generality, maybe generality. Removing the generality out of the source, so I can compare them to each other. You know, play.go.org. Okay, so what I need to understand is that let's say you have x, or you have type x, that's like a struct, and it has a string, a string, b string, right? Then you have type y struct, and you have a string, bb string, right? So if I said var x any and I made it like an x of a, which is a, and b is b, okay, and var y any, so I'm removing from them the type, but a is a, bb is b, so they are the same structures with the same number of attributes and the same types, and the attributes or the fields has the same values. So if I compare the x and y, is it going to return true? What was it? X equal y? False. They are not equal. They are not equal. And they are not equal because they are not the same type, right? Okay, if I named the fields the same way, is it? False, it's not equal. Okay. This should be equal, right? It's equal. Okay. Okay. So it's different type, but still when you compare them, even if they are any, it's going to compare them correctly. So if they are not the same type, it's false. This is perfect. Okay, so we are in the right path. We are in our, yeah, it's the right way. It's the right way. We're good. We're good. Okay, so you get the source head. Get same source head. This is the tail. Right. Get get. We. Yeah, that's a problem. Just a second, because we were using registry. While if you okay, yeah. So this is the thing. Do I use the type registry or source registry here? Yes, source registry, right? Source registry. And here you can have get registry, which does the inverse, so you can jump between both types. It feels like mental gymnastics. Get source. Get registry, you are returning R. I think Source registry. Okay. Yeah. So here links to registry, here links to source registry. All right. So what you should be doing here is returning source registry. Okay. Okay. So you have the source registry here, and you start to assign. You start shooting. Same source head get. Okay. So we got a head, right? We got a head there. So now we need to put it exactly as we did previously. Same source head doesn't equal nil, then yeah, if we found a source head, now get the tail, which is the previous one, and then it could be the same if it's the same if it's the first item, but bear with me. Also, if it's nil, we actually should be setting previous and next to the same rule, so it would be pointing to itself. Now if it's the second item, is going to get the rule as head and the rule as tail, and it's going to set this rule next to the head and the head previous to the rule. Yeah, so you put it before the head, and then the tail, you're going to set the rule previous to the tail and the tail next to the rule. So you're injecting the rule between the head and the tail. So now you have two different linked lists. Double linked list. Double circular linked list. One that goes over all the rules and one that goes over the rules of the same source. That's pretty nice. Make lint get next same source is not really yeah, we are going to use it, and get registry, we are going to use it. Just leave it there for now. Make run. Oh, we got our first panic. So this is our queue. So we add nil away. Nil away. We need this. We need nil away. Node. It's a tool. And you say go mod ID. It will download it. And then in make file, you can format, and then skipping to the heap, lit code and tool nil away. I think it works that way, right? Include package and run the linter by blah blah blah. Yeah. Go lang lint nil away. Its current form can report false positives. It's unsustainable. To be offered. Wait, so Golang CI lint already has nil away? Already has it? So there was an issue. And then it's closed. Mm-hmm. Mm-hmm. So it's just for linting, they don't want to add it, but what? But here it is. What the hell? So you can edit as a plugin, create custom, blah blah blah. False positive version from is a plugin to be executed as private linter. There are two plugin systems, and it's much easier to use. Module plugin system introduced since, and this only supported approach to run away and Golang CI. Okay. So can I do this? So I have to create this file, or I can just use the same file? Add nail away to the linter configuration file golang ci.yaml and linter enable nail away and then the custom. Okay, I'll buy it. And then this one has to be for module plugin system support. Yeah, I don't know what you're talking about. Going to this, and we are installing which Golang? It's 2.12.2. Yeah, let's keep it latest. Alright, and then I need in the linters to enable nail away. Enable nail away, and in the settings I add this custom. The settings I add this custom. Okay, something must be a map of string. Sure. Sure. I think I can do this just to make it empty. Okay, you are saying that if I do this, I don't need to do that. And I don't need this. Okay, let's see. So make lint. Build linter plugin nail away not found. Command is terminated due to error. Build linter. Uh-huh. Mm-hmm. Mm-hmm. Yeah, this is a waste of time. Just delete that. Yeah, exactly. Make lint, and we are running it. That's like normal human beings. Are you telling me that there is no nil away issue? Go to nil away. So make run. What is this? So Nilaway didn't catch it. Damn. Anyway, to do. Can I do this? Control C, Control C. That code in Nilaway. We're done with Nilaway. Let's come. What's going on? Using standard value instead of reconfigure hook variable. So, make it insert. What the hell is going on? Maggot is acting up. Okay, let's do that and get. Okay. Right, let's restart Emacs and see what happens. So okay, so what's your problem? Restarting again, let's see. Right, get status. Okay, it's working, so it was a hiccup, guess. So Nilaway. Oh god. So we are going to add nil away and push. Okay, so what's up with that? Invalid memory address or null pointer dereference, which is the exact purpose of nil away, but all right. Okay. Exact purpose of nil away. So what seems to be the problem, sir? 149. This one. 149. Okay. So the tail. I don't get it. Yeah, because we return early here, I guess. Yeah, because we return early. I think this could be organized better. So if the head is nil, you're returning the rule and making it link to itself. Yeah. Yeah. Yes. Yes. Perfect. Make length. Okay. Okay. So now we have, when you register a rule, it gets linked to all the other rules and it gets linked to all the other rules with the same source. So that means if you're trying to activate rules, you should be, the function you create for the head of every rule that has the same source. How do I describe this? So you go over the rules and you are starting them. So you start the rule and you skip all the other rules, and when the rule is getting executed, it executes itself and all the other rules in its same source chain, right? So you should be executing the rules that are first in their own source chain, right? Yeah, right. But I think to do that, we shouldn't have the linked list circular, because you need to know the first and the last item in like rules of the same source, so they can be circular. So we have to change that. We have to change the part that is making this is yeah, so it shouldn't be circular, it shouldn't be pointing into itself. And here we're trying to get the tail, but we don't need to. Yeah, we don't need the tail because we're not making it circular, and we don't need that for the same reason. Set next source. Yeah, so what you need is just same source head. So set next same source head. Yeah. So the rule next same source head. Yeah, we don't want the head, we want the tail. Yeah, we don't want the head, we want the tail. Same source. Wide LSP start or something. What's going on with the LSP? LSP mode. Okay, maybe just hiccup, and if we open it, yeah, okay, yeah, exactly, yeah. So we don't want the head, we want the tail, and this is going to hurt because now you have to go, and this is why I made it circular in the first place. So okay, so if it was circular and you want to get it, so you're going over every rule, and you should get to a rule that this is the first time you see its source. No. The thing is, adding and removing rules should be also. Yeah, this will be only when you are adding or removing rules. You will pay this cost, the n, based on how many rules do you have. Okay, let's pay that for now. and see where it gets us. So the tail, you're going over all the chain, and you need to get the last one, right? So so actually that means get previous. So that means you need to go from the last one up to the head, right? So you should go backward. You're going backward. Yeah. And you go backward. Yeah. So you should do that. And you start from there and you go back until you hit the tail again. Okay. So yeah, okay, let's name it something like this is tail. This is the tail. And you are going over, and every time you go to the previous until you hit the tail again. In that case, you break. Right? Yeah. You're going over the tail, and then you're trying to find the first one when you're going over backward. That is the tail. And you got the tail of the same source. And here, same source tail. And you add this rule after the tail. So this rule, rev, same source is the tail, and the tail set next is the rule. Yeah, so you're adding the rule to the end. So if you're going over all the rules, and this rule previous same source is nil, that means it's the head of its kind, and you can initialize it. This is nice. Dent is fine. All right, and make run works. I need to add tests. I need to write unit tests. The thing is, writing unit tests is really boring. Really boring. So it's not as exciting as writing the code itself. Ask any developer, they will tell you. Tests are boring. Everybody hate to write it. Or it's just me, I don't know. Everybody try to be genius in this career. Sound genius. So rule set previous tail set next. Okay, so this should work. All right. So now we need when we start. So function start for current and the start. Yeah. So what we need to be sure of is that you are going over everything, and this is the current start. Yeah, but if the same source and get source registry. Okay, and source registry get previous is nil. Come on. What is going on with Emacs? If source registry get prev same source. If it's nil, continue. Why? Because if it's nil, that means no. If it's not nil, so if it's not the first rule of its kind, then continue. If it's not the first rule of its kind, then continue. Otherwise, start this rule. And the starting is starting the source and executing the rule. Yeah. So let's go to the implementation here. So it gets the when it start, and then it adds the context, and yeah. So when start. Wait, I'm lost a little bit, sorry. Okay, so here is the start. This is starting everything. And then you're starting the rule, right? Here. And the implementation is here. So when you start the rule, it starts the rule with the rule to call back. Here you go. Yeah, rule to call back. And if you go here, so it makes a callback, right? And then process the then. Yeah. Rule to call. So yeah, this is what we need. We need this, and if this rule has the same next source, it should execute it, right? Yeah, so you're executing this rule and should execute the rest of them. And here we'll find the problem is that if you're executing multiple rules, you need to find a way to handle the errors. Here, any error we encounter, we are breaking the chain right away. Here, this failed, we are exiting. Wait a second, why do I need this rule to call back? Can't I have just the rule itself as a method called callback? I can't do that. So can I do that? So instead of this, here, and more rule in out, yeah, and callback, okay, and or yeah. So you're starting or callback with the context. Wait, what's your problem? Okay, so it's this callback, right? Yeah. Mm-hmm. Yeah, so you're starting the source with the context and giving it a callback so it can send any event it wants. Yeah, that's way simpler. So then this is dead code. We don't need that. Let's look for another simplification. Wait, is there anything the linter would like to say? Nice. Okay. All right. All right. So now we have this abomination of a rule: source, action, destination, registry, source registry, and then the implementation of all of these rule functions. And then a way to add a rule, way to get the same source tail. And start, wait for source to finish, collect errors. All right. So here you're calling a start, and this start is calling the source start. Yeah, and here the callback. The callback is just taking the context and event, processing the action, sending it to the destination, and continue. Then if our next same source doesn't equal nil, so you can do that. So if there is another function next, like if there is another rule that has the same source, then execute it. You know, like it's a chain. It's recursive. I guess. Yeah. Yeah. Yeah, that's a problem with generics. So from this rule, I need to execute the next rule. The next rule should have a callback, and the callback is generic, right? It is generic. So that means it has the same input. Okay. So what I need is that this callback, because it's generic, so it needs its own interface, which I hate, but bear with me. We can fix it that way. So call backable, which is in callback event in, exactly. And oh, and it's an interface, right? So yeah, it's a generic in. Okay. And here, if it's not nil, and if exactly, so we will try to cast it. If we can cast it, then we can call it. You see that? Are you sure about that? Yeah, I think this casting may allocate something here or there. We will see now. So yeah, so if there is a next same source, there is another rule that has the same source type, right? There is. So if there is, now let's cast it. We need to know that it can process the event of the same type, because the rules, they can be of different sources and every source can have different type. So you're trying to jump to the next source, and the source is, yeah, so it's really complicated. Why is that so complicated? I really like this lens, the Sigma Prime, and the 16, I think, 1.4. It's a really good really good lens, but it's really heavy, but it's very wide. So if I opened it and it's too dark, you will still see me. It's pretty cool. I really like this. Like it's good engineering, you know, something that's simple and it works. It has only one ring, just, you know, for focus. There's no zoom, there's nothing, just good engineering and good material, and it does one thing and does it well. Yeah, Richard Stallman would be proud of them. It's a Japanese company, I think, this Sigma. All right, let's get back to work. Let's get back. Okay, so if next same source is nil, return nil. Otherwise, if it's not nil, then let's cast it and execute it. Otherwise, no. Yeah. So with that, we should see that the source is initialized once. So source should be initialized. So source time here. So we should see that it's initialized once. Yeah, initialized once, and two rules are running. So one source, two rules. It's waiting for something. It should have closed. What is it waiting for? Yeah. Nil. Nil. That's a lot of go routines. That's a lot of go routines. Where is it waiting? Here. Rule 195. 195. Oh, no. 195. Here you go. No. No, it's not waiting for this. So if the previous of the same source doesn't equal nil, continue. Otherwise start and return the channel. And then next and break. Yeah, so what's wrong? No, there must be something else. I must have done something wrong. What is it? I'm looking for a path that says fire hose slash something, and I don't see it. Okay, how about we take all of that there you go. So it's only these, and here 195, and you are waiting. What's wrong? The source didn't. What's wrong? What is wrong here? This is the worst thing, when the program just blocks and you have no idea why it blocks. And now fire hose and then rule 196. Get source. Really? No. Why would that be blocking? Why are you standing there? Really, 196. So you get a rule and you start this rule, and then you go to the next and you start this rule. The start of the rule is to start the program. Start the source here. Starts the source, which gives it the callback. Yeah. Start the source, which gives it the callback, and that's it. Right? If R has like a previous same source is nil, right? So we don't need to activate it if it already has, if it's not the first of its kind. So you don't need to do this. So you start it, no error, and you're getting the next. Yeah, and the next is going to start, no error, so it's going to get, then going to break, and then you wait for the context to be done. Wait for the context to be done. One, two, three, four. Wait, we have two rules. Where's the second one? Okay, is this the problem? Okay, so let's do this. Let's do that. Slog dot info and history and all rules is in the registry. Here we go. Missing return, no problem. Invalid memory pointer, blah blah blah. Sure. Error closed, whatever. Okay, so yeah, there is something that can help me here. So there's something that can help, which is devs log. So this package will you can edit, and it will convert your structured logs into something beautiful like this. It's really useful. So you can do that. Can add it here, and then logger and set the default. Yeah. So if I run this now, go git, and if I run it, make run, it should print. It doesn't print the private, the unexported. Doesn't print the unexported. Why it doesn't print that? Exported. What are the options? Sort keys, new line after log, debug color, string formatter. Internal and unexported fields. Yeah. Tries to read unexported fields, which could cause a problem. And it's resolved here. So it won't help. It will not help. Okay. So let's print it. Info. So we have two rules. There's the first one, second one, blah blah blah. Next. Yeah, so sorry, what? How? So the next and the previous is the same? And this is the next and previous is the same? Really? How's that possible? No, something is off. If the head is nil, you do that. Yeah, only if the head is nil. Otherwise, you're getting the tail. And okay, so if you already have a head, you're getting the tail. And if you already have one rule, the tail is the head. Right? Yeah, the tail is the head. So same source tail. We don't have to think about that now. And rule sit next head. Head sit next previous. Yeah, so now you are linking it correctly. That it is correct. And the head, so the rule next is the head, and the head previous is the rule. Okay, and then this head is the tail still. So the rule previous is the head, and the tail next is yeah, that's correct. Is the implementation for this wrong or something? So what the hell is this shit? Why is the first rule pointing to itself? Because you add, blah, blah, and then you're returning the head. Wait, what just happened here? So we are adding, like this rule is trying to be in the end, right? Yeah, so you are returning the head. Yeah, that's correct. Next, the same source is blah 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 20. Yeah. This could be because the other rule has. Okay, that's actually correct. They are just two nodes. So the next and the previous are the same for both of them. Yeah, which is the other node. Yeah, that's correct. Next same source is nil. Next same source is this. Previous same source is nil. The context is nil. This context shouldn't be nil. This context here, it should not be nil. No. No, sir. Where are we set? So where are we setting it? Yeah, so we are starting. We start blah 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 blah, and our context is the source context. Yeah, what's wrong? The context for the first one should be a context, the second one shouldn't. Just need to see something. Yeah, so it's panicking. Yep, it panicked and panicked with a context. So when you do this, what the actual hell? What the fuck? This is the first rule and you just assigned it here. What is wrong with you? What am I missing? Yeah, so I'm panicking. And it panics with the same thing. Okay. But it doesn't show up here. So is that a copy of the rule? This R. Wait, what's going on here? It worked. Wasn't that like sticking here and like getting stuck and couldn't finish? What's going on? What is going on? Also, why is the other rule not getting executed? Starting time source with blah blah blah. So here, current start. Here. So if the previous is nil, return nil. If the previous is nil, wait, if the previous is nil, so you start so you don't start this rule unless it's the head, right? Is first same source, previous is nil. So if it's not is first same source, then return nil. Yeah, so naming it makes it easier a little bit. So when I do this, exactly, two rules should be running. Exactly, yeah, exactly. So let's catch it before it gets broken again. Let's remove this. Okay, I need to see something also. Make limits. Get next same source and get previous same source didn't help, right? Because we didn't call the functions, but should I use the functions here instead of the fields? Nah. Get So here sd getter get next same source, get previous same source. Get next same source and get previous same source. I think my heart started to realize that I'm drinking a Monster Energy. Yeah, it started to realize it. So make run 2, 3. All right. This is nice. This is pretty great. We can simplify. We can simplify. We can simplify some of this. It's really weird that the Golang CI didn't tell me that there is cyclomatic complexity here that is really all of these functions didn't really exceed the cyclomatic complexity. That would be interesting. Anyway, let me so let me have the rule here, but then let me remove anything like these functions. Add rule, get same source tail. Get same source tail is in add rule. Okay, start, wait for sources, collect errors, channel. And these are, let's say, this is the rule. And the other part is what, the engine, or let's call it engine until we find something else. Add rule, registers, and right, so there you go. So all of these functions are used here. Yeah. So lint. Okay. All right. So fan out implemented. Coding without the AI is actually really slow now that I think of it. So we are done with this. Add tests. Yeah, now we need to make this code like presentable a little bit so that we can write unit tests for it. How about we let the AI write the unit tests? If I didn't do that, I'm gonna lose the skill. No, let's write it. Let's not be lazy about it. Let's write it. Let's go. Go testify, which is a really nice package that we use to write tests. Nice package. Oh, they have a... My back is scaring me. The next stream, it will be from the bed. I will be just sitting in the bed and I will be on my laptop. Okay, so assert package. Oh, hello. Master Moose? Okay. Hi, how's it going? Okay. So, Testify has the assert package and require package. Yeah, this one. This is really nice. Okay, so let's write tests. Let's write some tests. Let's get something that we really want to test. Does the rule has any like complex logic that we need to test? So get next and set next, get previous, set previous. All right. Set next source. These are like one-liners. So look at that. So if I actually did this, they will align with each other, and the file will look really smaller. Yeah. So all of these implementations are really small. Mm-hmm. Yeah. Can I do that, or is it gonna? Yeah, exactly. It's not gonna do anything. All right. Start. Callback. So the callback runs the current rule. So here start. If it's the first, if it's not the first, then you can skip this one. Otherwise, you can start the source and store the context. Actually, we can do something like this. You can have the error named. Okay, check this out. And R cityx. And if you do that, it will be shorter and you wouldn't need all of this like if else stuff. So it assigns the error and assigns the context in one shot, and when you return without any like return values, it's going to return error, like the current value of error. Depends, of course. It's like nil, it's return nil, otherwise the error. There's something I didn't consider. Like I'm listening to this music here. It's also running in the stream. How is that? How is this even working? I think I should stop this. Mm, So what is that block? Ban. Yeah. Okay. All right. So this is the callback that is needed by the source. All the source needs is a function that takes a context and event and return an error. This is all. Yeah, we're going to improve that. And the callback is doing that, and next time source. You know, I want to see all. I want something that tells me all the other optimizations, like all the other messages from the compiler. Not just escape to heap. I want to know what am I missing. What is it called? Is that like go escape to heap? GC flag escape analysis. So what is this called? No one describes all optimizations that applied or didn't apply. Yeah. Opts. And I just don't want to filter it. So make opts is telling me that there are other issues. There are other issues. Can inline, nice. So what I need is that the things that it can't do, you know, the things that it can't do, not the things that it can do. So source does not escape. This is good. I want to see the bad. No. So leaking param. What is a leaking param? Rolling. What is a leaking param? So the assignment flows from a param to the heap or to any of its functions. Yeah, I don't know. If you're hunting down locations, ignore leaking params and look for move to heap. Yeah, but I want to understand what is it. Yeah, so leaking param. Yeah, here you are. Are you going to explain what is it, or you're going to just output that like what? God damn. Okay. All right. Somebody's talking about it here. Nobody's talking about it here. Okay, then let's look at it exactly. What is it? Leaking param registry. So what is the first one here? Engine, line 33. Engine, line 33. So this is leaking param. Why? Why is that leaking param? What do you even mean? So here, it's only used here. Source does not escape. And this is still line 33. Yeah, which is nice. Okay. Then leaking param line 77. Same. Leaking param registry and leaking param context and leaking param. Yeah, I really need to know what is that exactly. Okay. So this is good news. All of that is good news. I think except for the leaking param registry part. What is it? Like, I need to understand it. So what is it? So the leaking param diagnostic is a message from the Go compiler escape analysis indicating that the pointer or reference parameter passed into a function is being assigned to a destination that outlives the function itself. So the parameter or the argument is being assigned somewhere that outlives the function. Okay. Aside the word leak, it's not a memory leak. It's a normal compiler optimization mechanism used to determine whether memory should be allocated on the fast stack or the garbage collected heap. Excuse me, what? When you compile your code using the compiler construct a flow graph to trace data lifecycle. If a function parameter is a pointer, a slice, a map, a channel, or interface, the compiler watches where that reference flows. Doesn't escape, the parameter is only read or modified locally. The data can safely stay on the calling function stack frame. Nice. Leaking param that the parameter flows into a return value, a global variable, or is captured by a closure go routine because its lifecycle extends beyond the function call. The data it points to must escape to the heap. Leaking via return. So you take it here and then you return it. So leaking via interface. So okay, so you're getting the writer and bytes, and you're writing. Why does it leak W here? The program is memory. It forces the compiler to allocate the reference object on the heap instead of the stack. Performance heap allocation increase garbage collector pressure. Yeah. Okay. So what it says is that this registry outlives this function. So I don't see how. I'm trying to understand, but I don't see how. Like, this doesn't outlive the function, does it? Doesn't. Yeah. So line 51, engine line 51. The registry. Let me highlight it here. So we got it, and wait, and it's okay, maybe because this is passed here, then this is here, and then this goes through a go routine. So it could be because this goes through this go routine, then escapes from here, 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 so the whole graph. This could be it. Because of this, collect errors is in another go routine which outlives this function, which outlives the life of this function. Yeah. So this escape is reasonable. Yeah, exactly. Yeah. Yeah. So it's because of that. So if I eliminated this go routine, it should work. So wait for sources to finish. I'm creating a channel and returning it, and then having a go routine running to wait for everything and send to the channel. And I did this go routine call because I can't return with a channel that is unbuffered until like I return the channel, and then but there is another way to do it. You can so I can take the channel as an input, write to it, and in that case I can be blocking, right? And the caller should solve it by itself. The caller should find a way to, like write another go routine, whatever, instead of my code creating the go routine. That makes sense? So wait for source to finish. So if this is taking a channel for write, and this is taking a channel, and then start is going to take a channel instead of returning it. Yeah. So it's a channel, right? Is it like that? You don't return, you just error channel. And you write and you return. And here you write and you return. Actually, that means the caller can decide what to do with the error. Should it stop or not? Yeah, so but when do I close the channel? This is also the thing. So if I didn't do that, and here it's not really returning or anything. Here error chain, which is the error channel, and then error chain, then channel. Collect errors. No, you don't need to collect errors. All you need is to just push errors to the error channel and close the error channel whenever you're done. That means this chain 1 is not needed anymore. And that means if I do this, still there is a leaking param. It's in line 33, and it goes to 69, and then it goes to 51. 51. Okay, I think it's less. Is it less than before? Yeah, I think a lot of stuff are just was removed. Yeah, inlining and stuff, but how many leaking we had? 1, 2, 3, 4, 5, and now we have 1, 2, 3, 4. By the way, we need main to use it the right way now, because now this is not working. So errors, make a channel, so we're making a channel and then errors. Yay. What's wrong? Yeah. So we are going to go in and then range over errors. So we are starting and then waiting for it to be done. And then we are going over all the errors and we're trying to print them. That's it. Let's see. So how many leaking now? So it was 1, 2, 3, 4. Now it's 1, 2, 3, 4. So leaking param registry. This is line 33. Ah. It's in which file? Engine. .33. And then it talks about line 69. 60. Okay. So 69. And then 51. Yeah, I don't know, man. Like, I think I did all I can. Like, there is nothing. Maybe because of this context done. Also, why are we waiting for the context to be done? Why are we waiting here? Do we need this? Don't think we need this. So you start everything and then you wait for them to be done. Yeah. And this is it, right? Now you have 1, 2, 3, 4. Same. 1, 2, 3, 4. Same. So we have 1, 2, then these 3. Okay, let's look for this context. 51. 51. It says that this context is leaking, and that is absolutely okay. You pass it here, and when you pass it, it gets, I think, captured or something. Yeah, it's passed here. Yeah, this is an interface, so anything can happen inside. So I think that's the problem. If you pass the variable to an interface, it doesn't know what's going on. And now I'm not sure if I should revert the changes to the interface where we're creating the channel and returning it and so on. But I like the idea that we're not creating the Go routine ourselves. We're just coming from the outside, no? And whoever used the function can decide like how to handle this. There you go. All right. Let's see the linter. 76, name the return error with type error found. Okay. What's your problem? Name the return error with type error found. No named returns. Why no named returns? Okay. Abby. Missing white space above this line, which is rule 83. The white space linter is one of the most annoying software that I have ever seen. But it makes the white spaces consistent, which is consistency is good. All right. Okay, so make run 1, 2, 3, 4, 5, done. Yeah, it's working. Now we need to write some unit tests. So do we write, let's write this for the public interface first. Do you use the AI for that? Should we use the AI for that? You know what, I feel lazy a little bit about these tests. Damn. Use testify require to write unit tests for the exported functions types. Export functions in this package. Avoid the subdirectories. Just the level packages. And use testify. Yeah. Table-based tests as much as possible. Because I really like this table-based where you have one test and then you have like a list of structures that define different inputs and expected outputs, and then an iterator that iterates over that to create like sub-tests. I feel this is more elegant than whatever the hell the other way to do it. Go list in. Yeah, it will create unit tests for add rule and the start. Okay. Is there a bug? Now I need to update the test to use blah blah blah. Okay, sure. Welcome to modern programming. Okay, like let me clean this up properly. Come on, man, you don't have to tell me go and clean it up. Clean it properly, of course. You don't clean it like dirtily or anything. Good progress. The adult is passed. Now I need to fix the instance. Okay. Mm-hmm. Which is expected. Yes. Okay, okay, okay. Okay. Nice. That's pretty interesting. It is interesting that make and test. You know what? Sure, why not? So v blah 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 cover race. There was the race. V dash race and count one. Okay. Dash race and count. It's like count is how many times to run it, just to make sure it's not flaky. Let's run it 5 times and see how this goes. Make test. Yeah, it ran the same tests 5 times. I don't need the V. Mm-hmm. Mm-hmm. Yeah, coverage 82%. Nice, nice, nice. Okay, we're good. This is good. Go tool coverage, right? What was it? So go tool cover. Go tool cover. And this is the coverage. So, what is it that you didn't cover exactly? Yeah, I don't need to look at the actions. The engine is 100% coverage, and the rule is 55. Get registry never really called. Did we even use this function? Next time, yeah, we used it once. And the callback. How did that even work? If the callback didn't work at all. Yeah, so this motherfucker didn't write the full tests. It just invented it. Okay. Okay. There is a crucial function callback which is not covered by unit tests, while it has all the logic of executing the law. Let's look at the tests that this thing wrote. Mock implementations for testing. Sure. So you are mocking a source. Mock source, blah blah blah. And the source doesn't create any event, does it? Yeah, doesn't create any events. Mock action. Mock destination. Okay. And then test add rule. So you add first rule to null registry. Add second rule. Wow. So you just, the fuck? Yeah, the table test, the table driven tests are actually bullshit here. You just created functions in the structures instead of creating like data. He just created code in the data instead of having data and then the code's running on it. This is dumb. Sure, go for it. The change unit tests. The test tests instead of table driven as the setup. Quality assurance. Technology. All right. Oh, there's another follow. Oh, it's now 47. It's like 45 when we started. I only see it when I move here. So why? How? I need to learn how to use Twitch properly. Anyways. So how's Twitch actually? Let me try first to... Okay, so it's already turned off. Alright. So... was that like a V-streamer or... Alright. So let's see software development. I want to listen to that. I want to see how people are doing. Oh, I think I know this third one. Debugger programming. Finishing up localization foundation. Web design. I've seen this guy on Twitter, I remember. Ryan Fleury. Everybody's active now. Is it like day in US? Is that why everybody's awake and coding? Yeah. I guess so. I should start to stream at the time where people are awake in our time zone. Mhm. All right, it's done. Quality metrics maintained. Nice. Quality metrics maintained. Yeah, sure, sure. Make test. 100%. So, what did you do exactly? So, rule. It's interesting. So you didn't really write rule test.go and engine test. You just engine test and you try to cover everything in it. Sure. Sure. So how does that look like? So you have this mock with cancel, and then you're waiting and you cancel, and then if the context does you cancel. And you return the done context. Then you stop, you also close it. Action, process, processed. Event, and then you append the event to the processed. Mock destination, same. You know, instead of the mock, you can have something like memory source, memory destination, where you read from a slice in memory and you write to a slice in memory. Instead of this mock, you know, just make a source and destination that actually read from memory and write to memory. You don't have to mock it. Mock incompatible registry is a registry that doesn't implement clickable. So you can go to the other path. Sure. The path where you try to cast to clickable and you can't, so you have to return nil so to be able to cover the rest of the lines. I think that's what I tried to do here. So test add rule, and then what else? And test start, and wow, test rule callback. Yeah, why the fuck this is here? It should be oh my god. Okay, be around, and then let's go up. This shouldn't be here. Rule test go package. This is a file modes. Yes. Right. Yeah. Okay, that's a lot of lines. Process. Blah 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 blah. Okay, so test add rule. Add first rule to nil registry. Add first rule to nil registry. And this will new mock source and mock action and mock destination. And then you add the rule, you get a registry. There is no error, it's not nil, and the next and previous is equal to this. Yeah, okay, perfect. Second rule to existing registry. Yeah, so you add them and they start to refer to each other. So you add the rule, the first one, and then the second one. Not nil, and result.get next is result. Yeah, so there is no error, no nil, and you get the next is not nil and previous is not nil. Sure. But then the next of the result is the result. No. Who told you that? Who the fuck told you that, man? This must be a bug. Must be a bug. Oh, yeah. So this result get next is not nil, get previous is not nil. Get next should be the rule, right? Because the result is the first rule, and then when you get the next, it's the yeah, something is off with this one. At third rule, yeah, okay, here, you have one, you have two, and then the last one. If a circular structure has three elements. Okay. So the current, I have current at next. Current break, okay, equals 3. Okay, this looks like it's working, but okay. So start rule with source error. So you add that context start. Okay, you start. You try to get the errors, and then received errors, append timeout, waiting for the start of the. This is where it starts to become hazy. Like that's a lot of code that maybe we can just condense it. Do a small abstraction that help you. This is like it's just painting the wall with code. Start multiple rules with same source. Okay. Collect errors with timeout. Alright. Yeah, only one context cancelled since source is shared. Nice. We should only started once. True. Okay. Did it find the issue with the test? Did they just remove the test? It could do that. It's stupid and it can do it. Engine test. Okay, are you sure? You sure about that? Process, send, add first rule to nil. Cool, it points to itself. Perfect. You have two. With two circle rest, each should point to each other. Not equal. Not equal. I was reading it as an equal. Ah. The test instead of using not equal when checking for next ref, it should check equality with the rule address instead. Yeah, because like not equal, it could be equal to anything. It could be equal to nil. So you didn't really test anything in this case. You just ruled out that it doesn't point to itself. This is where the AI fails. It's kind of, yeah, it made like 100% coverage, but it actually was just bogus. Yeah, like, you know, I'm testing, but it's not actually testing, just saying, yeah, what it's not what it is. Exactly, yeah. So you make rule 1, register, rule 2, register, and so on. A third rule, register 2 rules. Yeah, exactly. 1, 2, 3, and then you need to check. So rule 2 points to 1, rule 3 points to 2, rule 1 points to 3. So they made a circular. 3, 1, 2. Exactly, yeah. 3, the previous point to 1. 3. What? Rule 1 previous is 3. Oh, okay, yeah. Makes sense. Test add rule, same source chaining. First rule with source has no same source links. Exactly. So these are nil. Perfect. Two rules with different sources have no same. Exactly. So nil. And the second one, nil. Two rules with same source are linked. So the first one, not nil and nil. And then it's checking the equality. So one next same source, you have the second rule, and the second rule previous same source is rule 1. Exactly, yeah. Rules, 3 rules with same source form a chain. Yeah. So 0 previous, nil, yeah. Oh, not nil, not nil, not nil, and then that's the last one. Then you are verifying the chain. Okay. Mixed sources, 2 with A and 1 with B. One more with A. Then test start. Okay, starting a single rule successfully. So it created the mock source and then created a rule, added it, then source stop. Yeah, it started, collected the errors, then stopped the source, collect the errors, timeout and error loop, blah 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 blah. This part is weird a little bit. Receive the errors, append the timeout. Yeah, you know, you can make a small utility function. You know, instead of this loop, make a utility function to drain a channel into a slice with some timeout. Yeah, that should, you know, compress all of this error loop thing. Yep, use this pattern everywhere, so you should have came up with that. Although it's a simple idea, but maybe because it comes out of the pain of maintaining the software, and the AI just doesn't care about that pain. Can repeat the code over and over like 100 millions of times, doesn't care. Exactly, yeah. Nice. Yeah, good for you. Start multiple rules with different sources. Start rule with source error, then drain, and you get one error. Drain error channel source should only be started once. Okay. And rule test, how does this look like? Successful callback with action destination. So this is when testing the callback, right? Yeah. Context background. Yeah, I noticed also that it uses context background instead of the test context. In tests, instead of using context background, use the T context. I think this is new. It's new to have a context in the test framework. This is why I didn't pick it up. destination sent once, process 0 is 42. So your callback was 42, and then you expect, okay, and callback was action error this, and there is an error, so you should sent is 0, processed 1. Callback was destination error, callback change to next rule with same source, manually set up the same source chain. Callback change stops on action error in first rule. Yeah. Propagates error from second rule. Yeah. Callback with 3 rules in chain. Callback was compatible next rule type. Yeah, if it's incompatible, of course. Okay, it's good. It doesn't panic. Context background. Okay, interesting. So, unit tests. Not proud of it, not my best work, but it's honest work. Okay. هل الشاشة سودة عند حد؟ Interesting. It shouldn't be. It shouldn't be. So it's excellent. Bitrate under. bitrate مش عالي فالمفروض لا. الغمراوي. لا غمراوي انا مش عارف، يمكن انت بتستخدم بتتفرج على الستريم فين؟ ايه الجهاز اللي بتتفرج عليه؟ هل اللابتوب قديم مثلا شوية او حاجة؟ لان انا اللي فاكره ان كان في مشكلة اول مرة اعمل ستريم، كان البيت ريت والريزوليوشن كانت عالية. بيت ريت والريزوليوشن كانت عالية. فيديو بيت ريت مقدرش انزلها دلوقتي صح؟ هل ممكن اعمل بوز ستوب؟ عايز اعمل بوز وارجع، بس عشان ايه؟ اجرب اعمل داون سايزنج للريزوليوشن. الكواليتي هنا الكواليتي عالية، فتقريبا عشان كده عندك سودا. ثواني